Okay, good afternoon. So let us discuss now yung ating next topic. So let us discuss our power plant. No? So when we define power plant, so that is establishment that in-houses the generators, motors, and different auxiliary equipment that uses for the conversions of mechanical energy into electrical energy. No? So power plant, we may classify power plant depending on the source of energy. No? So meron tayong thermal power plant, meron tayong hydroelectric power plant, we have solar power plant, we have nuclear power plant. So we have several types of power plant depending on the source of fuel. Then you may also classify power plant depending on the purpose. So, saan ba sila ginagamit? So meron tayong tinatawag na mga base load power plant, meron tayong peaking load power plant, we have also the reserve power plant and regulating power plant. So pag sinabi natin base load power plant, usually these are the power plant that operates theoretically 24/7, or these are the power plant that usually operate during normal conditions. Now they are the power plant that uses majority of the corresponding load requirements of a certain community or customer. Now pagka umabot na sa maximum demand yung kailangan ng ating customer at hindi na kinaya ng ating base load, so doon natin pinapaandar or doon natin ino-operate yung ating peaking load. So ngayon kapag nagkaroon ng, alam natin, when load changes, so kahit pa paano may konting changes yan sa system voltage. So para ma-maintain, no? Ma-maintain yung system voltage and system frequency, so nandoon siya regulating power plant. And at the same time, no, kapag wala pa sa maximum demand pero hindi na kaya ni peaking load power plant, so nandun din yung ating regulating power plant. Now in case of emergency, nagkaroon ng uh, malfunctions, or sabihin natin nagkaroon ng sira or unfortunate shutdown yung isa sa ating mga base load, so nandoon yung ating reserve power plant. Okay? So basically, balikan natin yung different topic kay power plant as we try to solve this given problem. So this is under power plant operation. So number one, so this is just objective. So for number one, which of the following is non-renewable source of energy? O yung tinatawag nating conventional, no? Conventional source of energy. So basically, out of the given following power plant available here, so alam natin kung alin dyan yung non-renewable. So non-renewable, that is actually yung ating nuclear power plant. Number two, geothermal power plant is most suitable for. So ito nga yung ating type of power plant based on the purpose. You have the base load, peaking load, regulating plant, and standby plant. So paano ba natin kinakategorize? Paano ba natin ina-identify na itong klase ng planta na to, pwede siya as base load, peaking load, regulating plant, or standby plant or reserve? So basically, for geothermal power plant, this is a type of plant wherein kailangan natin ng medyo capital to establish, malaking capital to establish, but minimum cost for the operational, no? Minimum operational cost, since its main source of energy is geothermal. So that is heat from the earth, which is libre, pwede nang sabihin libre kasi galing from the earth. So hindi ka parehas ng coal na kailangan mong bilhin. So basically, geothermal power plant, it is usually suitable for base load power plant. So it is used as base load power plant since geothermal, that is a power plant that requires large capital but minimum operational cost. Number three. For number three, we have a natural waterfalls. 50-meter high consistently discharges water at a rate of 1.3 cubic meter per second. A mini hydroelectric plant is to be constructed at the bottom of the waterfalls. So calculate the electric generator kilowatt rating, assuming 90% mechanical to electrical conversions and conversion efficiency, and water turbine design efficiency of 70%. So for problem number three, let us consider we have hydroelectric power plant. So tinawag natin siyang hydro since the main source of mechanical energy that is based on the water, no? The equivalent energy of a certain amount of water. For hydroelectric power plant, so let us consider, no? Jo pansin natin, we have a natural falls. So sabihin natin, no? So this would be the waterfalls. So hinayang tayo doon sa energy of the given falls. Kasi alam natin, for any given body, by virtue of its motion, so meron tayong tinatawag na kinetic energy. And by its given elevation, we have the potential energy. So nanghinayang tayo sa amount of water that flowing down from a given waterfall. So therefore, naka-isip tayo ng paraan, why not to harness this given energy and convert it into electrical energy. So nag-design tayo ng isang turbine, nilagay natin, no, sa baba ng ating waterfalls. And this given turbine, it is coupled dun sa ating generator. So this given turbine, it would serve as our prime mover. So let us consider, ito yung ating generator. Wherein it's given shaft that is coupled to the turbine that uses to harness the mechanical energy of running water. So based sa problem, kapag kinuha natin yung effective height, no, simula do sa position ng ating prime mover up to the highest point ng ating water, so that would be the effective height. So let us consider that is h. So based sa problem, this is equivalent to 50 meter. And we have found out that the amount of water that flows in these waterfalls, it is equivalent to 1.3 cubic meter of water per second. So nag-design tayo ng turbine that would harness this given mechanical energy of running water, and we have found out that its given efficiency, turbine efficiency, that is equal to 70%. And the generator's efficiency, that is equal to 90%. So hinahanap ng problem, what would be the corresponding output power of our generator? So what would be the corresponding output power? Okay, so kumbaga, this turbine efficiency do sa ating generator, kung babalikan natin, it represent the mechanical efficiency, no? It convert this given mechanical energy papunta sa electrical energy dito sa ating generator. Then the generator, it would convert, no? So the generator efficiency represent its electrical efficiency. Kaya kapag kinuha natin si plant efficiency or the overall plant efficiency, that is always equal to the product of turbine efficiency and generators efficiency for hydroelectric power plant, which is alam naman natin that the overall efficiency, it is always equal to the output over the input. So at this case, yung ating input ay nakadepende yan kung ano yung source of our mechanical energy. So at this case, we have hydroelectric power plant. So therefore, this input power represent the theoretical power of running water, no? PW, which is, alam natin, QWH, no? The theoretical power of running water. Wherein Q, that is the amount of water that flows per given time in terms of cubic meter per second. Height, that is the effective head or effective height at which water falls. And omega, that would be the weight density of water. So alam natin, weight density of water in metric system, that is always equal to 9.81. Anong unit yan? This should be kilonewton per cubic meter. So that would be the weight density for this given water. So therefore, wala na problema. We could actually compute now what would be the possible output or the capacity of this given generator that uses to convert this mechanical energy from running water into electrical energy. So solving now for the output power of our generator in kilowatts, it should be equal to whatever the turbine efficiency times the generator's efficiency multiplied to the input power, which is the theoretical power of running water, QWH. So, pwede na, this is 0.7 multiplied by 0.9 multiplied, no, yung ating discharge rate of water. So, ilagay kong unit para makita natin, cubic meter per second multiplied to the standard weight density of water, which is 9.81. Unit na nito is kilonewton per cubic meter, multiply the effective height, so that is 50 meter. So pwede natin i-cancel ang cubic meter. So anong natira? Kilonewton. Kilonewton meter is kilojoule. Kilojoule per second is kilowatts. So the final answer, it should be measured in terms of kilowatts. Okay? So pwede nang diretsuhin, 0.7 times 0.9 times 1.3 multiplied by 9.81 times 50. So we have 401.72 kilowatts. So that would be the possible output of our hydroelectric power plant installed in this given natural waterfalls. So 401.72. So we have arriba. Okay. So I want to see problem number 3. So that is on the hydro. So pag hydro, yung ating source of energy that is based on the running water, and you may compute the equivalent power of running water that is in terms of QWH. So number 4, a power plant gets water from a dam from a height of 122.45 at a rate of 1,000 cubic meter per minute. If the output of the plant is 15,000 kilowatt, what is the overall efficiency? So for number 4, again, this is still under hydroelectric power plant. So based sa problem, the effective height at which water falls before striking to the turbine, it is equal to 122.45 meter at a given rate of 1,000 cubic meter of water per minute. So we have already identified that the output of this hydroelectric power plant, it is equivalent to 15,000 kilowatt. So ngayon binaligtad lang, what would be the plant efficiency? So alam natin that is output over the input. At this case, the input is the theoretical power of running water since we are still dealing with hydroelectric power plant. So pwede na nating diretsuhin. So we have already the corresponding output, which is 15,000 QWH. So dapat itong ating discharge or the amount of water that flows per given time, it should be cubic meter per minute. So kailangan gawin natin cubic meter per second. So I just divide 1,000 by 60 to make it per seconds. Then the weight density in kilowatts ulit. So 9.81 na lang gamitin natin. Multiplied by the effective height. Then times 100%. So meron na tayong final answer. So 15,000 divided by 1,000 over 60 to make it cubic meter per second. times 9.81 multiplied by 122.45. So we have 74.9%. So that should be our final answer, 74.5 or 9. So pwede na 75%. Okay? So, and question regarding hydroelectric power plant. So we want to go see number 4. Number 5. So the net energy required of a certain country in the year 2000 was approximately 3 times 10 raised to 6 gigawatt hour. What is the equivalent value in quad? So net energy required, or that is simply, pwede na sabihin, that is the total energy produced or the total energy provided by a certain power station in a given community. So TEP, or the total energy produced, so that is always equal to, pwede natin sabihin that the TEP can be computed as the product of AL multiplied S sub R. So sino yung ating A sub L? So this is the average load. Average load supplied by the certain power station. Then S sub R, so S sub R, that is the service R, or simply actual operating hours. So TEP, that is also electrical energy kasi average load measured in kilowatts and S sub R measured in hours. So this is also measured in what? Kilowatt hour or electrical energy. So actual operating hours, ibig sabihin, this is the actual number of hours at which a certain power station is operating within, sabihin natin, either within a day, within a week, within a month, or within a year. So nakadepende doon sa ating reference study. So this is based on the given problem, that is year 2000. So pwede na natin sabihin S sub R, that is the actual operating hours at which this power station operate within one complete year. So based sa problem, during the year 2000, the given power station actually provide a total energy which is equivalent to 3 times 10 raised to positive 6 gigawatt hour. Or this is also approximately 3 times 10. So giga, that is 9, ano? So gawin natin kilowatt hour. So minus 10 and 6. So therefore, this is raised to 12 kilowatt hour. Yung giga, so 9 yon, yung 62, sama natin doon. So matitira is in kilowatt hour. So that is 3 times 10 raised to 12 kilowatt hour. So that is the total energy provide by a certain power station to its given customer. So ano lang hinahanap? Let us try to express this given energy in terms of quad, no, conversion lang. So express this total energy. What will be the value of the total energy produced at what unit in terms of quad? So quad, that is a unit of energy. So kailangan lang natin dito is conversion factor. So just recall that for every 1 quad of energy, saan ba galing yung quad? So quad, that is only the root word for quadrillion. So ano yung quadrillion? Kumbaga sa pera, di ba? Million, 10 raised to 6. Then kasunod ng million is billion, no? The equivalent value. So billion, that is 10 raised to 9. Kumbaga, the numerical value for our prefixes, no? 10 raised to 6 is mega, then 10 raised to 9 is giga, then 10 raised to 12 is what? Tera, then 10 raised to 15 is peta. Now, in terms of their numerical value, So mega, that is million. Giga is billion. Okay? So tera is trillion. Then peta is what? Quadrillion. So lumalabas, no, one quad, that is just simply the root word for quadrillion. So pag sinabi natin quadrillion, it represents a corresponding value which is equivalent kanino? 10 raised to 15. So anong unit nga lang? That is in terms of BTU. So yan ang kanyang equivalent value. One quad of energy, that is the root word for quadrillion, which is the numerical value for peta, no, prefix peta. So prefix peta is 10 raised to 15. So 10 raised to 15, its value, it is known to be quadrillion. Okay? So quadrillion BTU. So yun ang ibig sabihin ng ating one quad. Now, alam naman natin, we may convert BTU into kilowatt hour. So kung babalikan natin, for every 1 kilowatt hour, it is always equal kanino? 3,413 BTU. So yan yung gagamitin nating conversion. So in that case, pwede na natin makuha that the total energy produced during this particular year of a certain power station measured in quad. So we have now 3 times 10 raised to 12 in terms of kilowatt hour. So multiplied na lang natin that there are 3,413 BTU per kilowatt hour. Then for every 1 quad of energy, it is 10 raised to 15 BTU. So si number 5, it is just a matter of conversion. BTU, kilowatt hour, cancelled. So kuha na natin ang sagot that the total energy produced by this given power station within that given year, it is equal to 3 exponent of 12 times natin ng 3413, divide ko na lang ng 10 raised to 15. So you have now equivalent to 10.24 BTU. BTU tuloy kapatid. Quad. No? So 10.24 quad, that is the equivalent energy provided within that particular year. So 10.24. So we have baligtara. Okay? So iwanan ko yung quad na yan. So recall mo na lang yung kanyang equivalent value. So that is the numerical value for quadrillion. Number 6. For number 6, we have a certain power station that provide electrical energy to a certain customer that demands a maximum of 100 megawatts, no? Or 80 megawatts rather. So we have a power station with a capacity of 100 megawatts, has a maximum demand of 80 megawatts, and produces an annual energy of 665 megawatt hour or 665,000 megawatt hour. What is the annual capacity of the given plant? So kunin muna natin, let us consider IC. So IC stands for installed capacity. So paano natin kukunin si installed capacity? Installed capacity, that is actually the summation of the rated power of the given generator connected to our power station. No? Kung meron kang 3 or 4 na generator, so kung alam mo yung kanilang nameplate rating o yung kanilang rated power, yung nandun sa kanilang specs, so you just take the summation for that rated power and that should be the installed capacity. No? So ibig sabihin, this given power plant can actually supply up to 100 megawatt of electrical power to a certain customer. Now, for a given community that is supplied by this power station, ang kanyang MD. So let us consider MD is the maximum demand or the peak demand. No? So that is the highest power required by the customer. Maximum demand, which is equivalent to 80 megawatts only. Now, this given power plant produces an annual energy. So that is the total energy produced annual. So ibig sabihin per year yung ating computation ng actual service hour, which is equivalent to 665,000 megawatt hour. So what is the annual capacity factor? So required plant capacity factor, or sabihin na lang natin PCF. Okay? So paano nga ba kunin yung plant capacity factor? So solving for the PCF or the plant capacity factor of a certain power station, it is always the ratio of the total energy produced by this given power station. I-divide natin whatever its installed capacity multiplied kanino. O ito gawin ko na lang capital R, no? Rated power. So para hindi tayo maligaw kasi ito rin ang ginagamit na symbol, P sub R. So P sub R, or simply sabihin na lang natin ito yung output power ng bawat generator. Parehas lang naman. Okay? Summation of the output power of every given generator, the rated output power. So plant capacity factor, that is the ratio of total energy produced over the installed capacity multiplied by P sub R. So sino tong P sub R? That is the total number within a certain period. Ano ibig sabihin? So, total dyan, ang pinag-uusapan natin is annual. So, ibig sabihin yung certain period, that is the given time, no? That is per year. So, kapag kinuha natin si P sub R, that is the total number of R within a year, no? Within a certain period. Kasi si PCF, pwede natin computein ang plant capacity factor ng, pwede sabihin natin, per month, per week, or per day. Okay? Or per year. So nakadepende kung kailan natin kukumputin yung kanyang plant capacity factor. Pero diyan sa problem, binanggit that is the annual. So pag sinabing annual, so yung ating certain period, hinahanap natin is within one complete year. So for 1 year, ano yung total number of hours? Yun ang tinatawag natin P sub R. Yung iba, ang tawag nila is the periodic number of hour, the total number of hour within a certain period. So kung babalikan natin kapatid, P sub R represent the total number of R within a certain period. So this should be equal, no, ilang days ba lahat meron? 365. Ilang oras meron sa isang taon? So that is 24. So this should be the value of our P sub R for year basis. So we have 8,760 hours. So that is kung ang period na pinag-uusapan natin is what? Annually. O per year basis. So kung per month, 30 times 24. Kung week, 7 times 24. Okay? Pag hindi binanggit, automatic ang consideration is per year basis. So that should be our PCF, no? The ratio of total energy produced over the installed capacity multiplied to the total number of hours within a certain period at which we want to determine the capacity factor of this given power station. Okay, so given naman yung ating total energy produced, alam na natin yung kanyang installed capacity, and we are looking for the annual, so no more problem. Pwede mo nang diretsuhin that the plant capacity factor, it is equal to, so total energy produced, 665,000. So naka-mega, so retain na lang natin si mega kasi ang installed capacity is also in mega. So that is 100 multiplied the total number of hours within a year, 8,760. Multiplied na lang natin ito ng 100. So yun ay hinahanap natin final answer. So 665 over 100 times the answer equal. So 75.9%. So that would be the plant capacity factor. So 75.9, so pwede natin sabihin, this should be 76%. Ay, pa ba? So parang sinasabi natin, plant capacity factor, it is actually analogous to efficiency. So ito yung kanyang capability, no? This would be the capacity of the given plant in producing electrical energy at ito lang yung na-consume, which is 665. Okay? So parang ito yung output, ito yung input. So ito yung input, ito yung capacity. So ito lang yung na-consume. So it represent, no? Pwede natin sabihin, plant capacity factor, it is also one way to measure the efficiency of this given power station. Okay? So iwan ko si problem number 6. Let us try number 7. So for number 7, to produce 1 kilowatt hour, a power plant burns 0.9 pound of coal with heating value of 12,000 BTU per pound. What is the heat rate of the given plant? Okay? So ano ba si heat rate? So heat rate, so let us consider that is our Q. Yan ang gamit niya, no? So symbol for heat rate. So sino nga ba si heat rate? So heat rate, that is actually equal to the ratio of mechanical energy over the electrical energy. Kung power plant ang pinag-uusapan, power plant is from mechanical to electrical. So lumalabas, whatever the mechanical energy input, i-divide natin kanino? Electrical energy output. So that should be the heat rate. So kumbaga, pag tinignan natin yung kanyang formula, so output is electrical, input is mechanical, yun nga lang, naka-reverse siya. So pwede natin sabihin para itong reciprocal ng ating efficiency. Ang pinagkaiba lang ng heat rate, the heat rate, it is measured in terms of what? Most of the time, heat, no? One way to measure heat energy is what? BTU. Then electrical energy, that is what? Kilowatt hour. Kumbaga, pwede nating analogy yung heat rate na yan dun sa tinatawag nating energy efficiency ratio ng ating mga pwede, no? Pagka bibili ka ng appliances sa mga store, let's say, bibili ka ng air conditioning or refrigerator, so agad, no, ang ibibigay sa iyo yung kanyang EER, no, the energy efficiency ratio. So that is the equivalent, no, mechanical energy per electrical energy consumed. Kasi yung ating air condition at saka refrigerator, mga motor yan. No? So yung output is mechanical, input is what? Electrical. No? So heat rate, it is analogy with the energy efficiency ratio. So that is measured in terms of BTU per kilowatt hour. Kaya nga pagdating doon sa mga ganong appliances, aircon and refrigerator, anong sinasabi? Habang tumataas yung EER or the energy efficiency ratio, ibig sabihin, mas tipid siya, no? So for a minimum amount of electrical energy consumed, it can provide, no, large amount of mechanical energy. Or pwede natin sabihin, it can remove certain amount of heat energy kasi alam natin trabaho ng aircon at saka ref is taga-remove ng heat, excessive heat dun sa certain matter na ipinasok sa refrigerator or yung taga-alis ng heat doon sa air inside the room, no, para ma-maintain yung lower temperature. So heat rate, that is the ratio of mechanical energy input in a given power plant over its corresponding electrical energy output. So kapag kinuha natin yung electrical energy output, so electrical energy pa rin yan, which is actually equal to output power multiplied kanina, time. Okay? Yun pa rin naman yun, kapatid. The specific formula. Then, pag kinuha natin ang mechanical energy input, so mechanical energy input, nakadepende kung anong klaseng planta ang pinag-uusapan. So, tulad dito, coal. So, ibig sabihin, meron tayong coal-fired power plant. That is one of the thermal power plant. So, for the coal-fired power plant, yung ating mechanical energy can be computed as what? The mass of coal used, sabihin natin, that is mass of fuel needed, multiplied natin doon sa kanyang HB. So, sino si HB? That is heating value. Ano yung heating value? That is the energy content. So, energy content, mechanical energy content. Kumbaga, heating value, that is the quality of the given coal. Kaya nga yung coal, meron tayong class A, class B, class C. So, nakadepende yan dun sa kanyang energy content. So, dito, based sa problem, the heating value of this coal, no, per pound of coal can provide 13,000 BTU of heat energy. So, hinahanap na yan, what would be the heat rate if it is required to produce 1 kilowatt hour. So, alam na natin yung kanyang output. So, its corresponding output, that is only 1 kilowatt hour. So, to provide this given amount of electrical energy, binanggit ng problem, the given mass of coal needed, that is only 0.9 pounds, wherein the coal used has a heating value of what? 13,000 BTU per pound. So what would be the heat rate? So pwede na natin diretsuhin. Heat rate, that is the mechanical energy input to our power station, which is the mass of coal needed, which is only 0.9 pound, multiplied by its heating value, which is 13,000. So cancel yung pound, i-divide na lang natin do sa required electrical energy, which is only 1 kilowatt. So meron na tayong unit of BTU per kilowatt hour. So 0.9 na lang times 13,000. So we have 11,700 BTU per kilowatt hour. So ibig sabihin, ano, we are needing 11,700 BTU of mechanical energy just to provide a 1 kilowatt hour of electrical energy for this given power station. So anong letter ito? This should be cut style. Okay, so one ko si heat rate. That is just the ratio of mechanical input over the electrical energy output. So number 8, so for problem number 8, the annual load duration curve of a certain power station can be considered as a straight line from 20 megawatt to 4 megawatts. To meet this load, 3 turbo alternator units, 2 is rated 10 megawatts and 1 rated 5 megawatts are installed. So determine the plant use factor. So annual load duration curve. So kung ipa-plot natin yung behavior nung load supplied by this power station, so using the X and Y axis, so the vertical axis, that is the axis for, sabihin natin, that is the output power or simply the corresponding power, P. And the horizontal axis, that is the corresponding time. So based on problem, we may consider that the load duration curve of this given power station can be straight line. Now from 20 to megawatts. So let us consider within a certain period of time, nung in-start natin i-observe ang kanyang load requirements, it is what? 20 megawatts. Sabihin natin, ito. Now, alam naman natin, load is variable. So, nagbabago yan. Siguro, yung 20 megawatt, tulad ngayon, summer. So, tuwing tanghali, napakainit, kaya mataas ang load requirement. So, habang pahapon hanggang sa madaling araw, medyo bababa yan. So, after certain period of time, sabihin natin, from T1 up to T sub 2, so bumaba na yung ating power consumption, which is up to 4 megawatts na lang. Pag kinuha natin yung point, ito. So, ito yung ating load duration curve na binabanggit ng problem that can be considered as what? A straight line. So, in order to meet these corresponding load requirements ng ating customer, so yung ating power station o yung ating power plant, meron siyang tatlong alternator. So, dalawa doon, rated 10 megawatts at yung isa 5 megawatts. So therefore, pag kinuha natin yung ating installed capacity IC, alam natin that is the summation of the rated output power of the given power plant or given generator available in this power plant. So meron tayong dalawang generator that is rated 10 megawatts. Then we have one generator that is rated 5 megawatts. So the installed capacity for this given plant, that is only 25 mega. So ibig sabihin, pasok pa rin, kayang-kaya niya. Kahit umabot to sa peak demand na 20 megawatts, okay pa rin. We have still reserve capacity of 5 megawatts. So ano hinahanap, kapatid? Determine the plant use factor. Or pwede natin sabihin that is what? PUF. So how to get the plant use factor? So PUF. So PUF, that is again the ratio of its total energy produced. I-divide natin kay installed capacity multiplied kay S sub R. So alam na natin sino si X sub R. That is the actual operating hours, no, at which the given plant is operational, no, actual operating hours. So alam natin, kahit sabihin natin base load power plant yan, so theoretically, pag sinabi natin base load, this power plant should operate 24 hours a day, no, 24/7 and 7 days a week, theoretically, no. Pero alam naman natin, kahit sa base load yan, meron pa rin tayong tinatawag tulad ngayon, no, yung ating ibang planta is under maintenance, lalo na pagka summer. So pagka under maintenance yan, hindi yan operational. Tama ba? So ibig sabihin, lumalabas yung kanyang actual operating hours less than do sa tinatawag natin total number of hours within a certain period. So S sub R represent the exact or the actual number of hours at which this given generator or this given plant is operational. Kaya tinatawag natin plant use factor. Now, alam na natin kanina that TEP or the total energy produced, it is also equal to the product of average load multiplied kanino? S sub R. So, divide natin kay installed capacity times S sub R. So, ibig sabihin, pwede rin pala natin kunin na ang PUF, it is just the ratio of what? Average load over the installed capacity. Kaya tinawag nating plant use factor. Kasi itong average load, ito lang talaga yung load na sinusuplayan niya. Pero ito yung kanyang installed capacity. No? The average load, this is the actual load connected to this given power station. Now, ang tanong, paano ba natin kukunin si average load? So, pag kinuha natin si average load, babalikan natin yung general formula. Since average load ito, kapatid, ano? So, ano nga ba ang formula pagkuha ng average value? Diba? Isa lang naman yan. That is always equal to the area. I-divide natin kanino? Span. So, saan area? So, yung area under the load duration curve. Ito ngayon yung area na kailangan natin i-consider. So, this given area represent the total energy used by our customer within this given period of time. So, ang tanong ngayon, paano natin kukunin itong area na to? So, obviously, pag tinignan natin yan, so kita natin that this given area ay anong klaseng geometrical figure. So, meron lang tayong trapezoid, ano? So, kayang-kaya natin kunin yung area ng isang trapezoid. Okay? So, how to get the area of this given trapezoid? So, kung babalikan natin, area of the trapezoid, so pwede natin kunin, ito yung kanyang H1. So, ito yung kanyang initial height. So this should be H1, this should be H2, and this should be H corresponding base. So kung babalikan natin for trapezoid, area of a trapezoid, that is always equal to 1/2 base H1 plus H2. Parehas lang din naman yan kung ito gagawin nating B1 at ito gagawin nating B2 at ito si H. The same pa rin naman ang lalabas. So dito kasi nakapatayo lang yung ating given trapezoid. So pag hiniga natin yan, ito naman ang lalabas na B1 at saka B2. And this would serve as our height. No? Wala problema. So the same. Now, pag kinuha natin yung span, so gaano kahaba ba yung ating curve horizontally? So lumalabas yung span natin, that is simply what? That is from T1 to T sub 2, that is T2 minus T1, so that is only equal kanino? B. So at this case, pwede na natin sabihin that the average load, it is just simply equal to 1/2. Retain natin si B, wala tayong value ng B, ano si H1. So from X up to the maximum demand, which is 20, plus, so H2 from X up to this lowest demand, which is 4, mga mega. So that is the area. I-divide natin gaano kahaba yung ating load duration curve along x-axis. So that should be the value of our B. So pwede natin i-cancel ito. So kita natin that at this case, the average load for this given customer, 24/2, and that is only 12 megawatts. So that should be the average load. Therefore, pwede na natin kunin that your PUF average load computed is 12 installed capacity, that is the summation of the rated output of our alternators. So they are connected in parallel, no? Hindi na kailangang banggitin yan, automatic they are connected in parallel. So divide na lang natin ng 25. Tapos i-times na lang ng 100 para naka-percentage. So 12/25. Yun na yun, kapatid, 48%. So that would be our plant use factor for this given generator. Mga 48, no? Averagely, 48% lang no kanyang installed capacity usually nagagamit ng ating customer. So average of 48%. Okay, naku ba? Any question regarding problem number 8? Number 9, for problem 9, the power customer has 4 circuits of 220 volts, 3-phase. The circuits have the maximum demand o kumbaga, meron tayong 4 na customer. So each customer has a maximum demand of 35 ampere, 46 ampere, 72, 57. Diversity factor of this given power station that will be used to supply this demand is 1.5, and the load factor is 50%, and the power factor is 80%. So what is the approximate kilowatt demand of the customer? So let us consider, we have line or feeder voltage or system voltage, line to line, that is what, 220 volts. Volts lang pala ito, 3-phase. So parang distribution na lang ito, no? So we have the following loads. Sabihin natin 1, 2, 3, 4. And the corresponding maximum demand of every load, MDL, no? Maximum demand per corresponding load. So for the first load, that is 35 ampere, no? In terms of ampere. Second load, that is 46. Third load, you have 72. Then fourth load is what? 57. So now, if this given power plant has diversity factor of 1.5, so sino nga ba si diversity factor? Okay? So diversity factor, ano ba importance ng diversity from divert, ano? So under diversity factor, kumbaga this is with respect to proper load handling, no? Kumbaga proper time management. So under diversity factor, no, it is always considered na much better na yung ating mga load na kailangan supplyan hindi nagkakasabay-sabay yung kanilang maximum demand. Na kumbaga parang sa bahay, so dapat medyo smart yung paggamit natin ng mga appliances. So dapat minsan hindi sabay-sabay, no? Huwag lahat pagsabay-sabayin lahat ng ating appliances. Okay? So kaya nga minsan pag may nagpa-plancha, so stop muna yung ibang appliances kasi mataas ang konsumo nun. So kung gumagamit ka ng mga induction cooker or electric cooker, so yung iba, so naka-stop yung ibang appliances. So yun ang tinatawag nating diversity factor. Kasi ibig sabihin yun, kapag ka nagkasabay-sabay yung kanilang maximum demand, so therefore mas mataas yung current. Mas mataas yung current na papasok dun sa ating circuit. So pag mataas yung current na papasok dun sa ating circuit, so ibig sabihin, mas malaki rin yung possible na maging loss. Kasi ang loss is proportional dun sa current. Okay? So therefore, para maiwasan yon, hindi naman ibig sabihin magbabawas tayo ng load. Anong gagawin lang natin? Ita-time management lang natin na dapat itong load na ganito, so sa ganitong oras, let's say, ang pagpaplantsa, ganitong oras. Okay? So yung pagluluto, so ganitong oras. Kailangan huwag magsabay-sabay. So kung hindi sabay-sabay operating yung mga appliances na yan, so hindi ganun kalaki yung current na papasok dun sa ating circuit. So hindi ganun kalaki yung ating magiging losses. So medyo nakakatipid tayo. So ganun din pagdating sa mga planta, no? Para hindi natin kailangan mag-provide ng malaking power or malaking current, so kailangan properly time manage yung mga load na kailangan nating supplyan, no? Kaya nga meron tayong tinatawag, no, kay WSM, may oras na mababa ang kuryente. No, kailan 'yon? Kapag medyo mababa yung demand, no? Mababa ang kuryente doon. Pero kapag nag-operate ka during peak demand, peak hours. So masyadong mataas, medyo mataas ang kuryente kasi nga malaki din yung losses during that particular time because of the current. So yung trabaho ni diversity factor, it is analogy to time management. Time management kung kailan mo dapat, no? Kung kailan dapat lumabas or kung kailan dapat mag-operate yung bawat load doon sa kanilang maximum demand. As much as possible, hindi dapat magsabay-sabay yung maximum demand ng bawat load na kailangan nating suklayan. So based sa problem, this diversity factor it is 1.5. So, paano nga ba kunin si diversity factor? So, the diversity factor, it is always the ratio of the summation of maximum demand of every load na connected to our power station over the equivalent maximum demand to the power plant. So, ito yung nagre-registered or this would be the maximum demand na kailangang paghandaan ng ating power station, ng MD. That is the equivalent maximum demand na kailangang i-provide ng ating generating station in order to supply the load requirements of this given customer. At ang diversity factor, it should always greater than 1. Mas maganda, mas mataas. No? Habang tumataas yan, mas nakakatipid. So that is the summation of the maximum demand of the load over the overall maximum demand in the given power station. Now, sino yung load factor? So let us consider LF. Based on its initial, LF is the load factor. So pag kinuha natin si load factor, that is the ratio of the average load na kailangan supplyan ng ating power station, i-divide natin doon sa tinatawag nating maximum demand. So that would be your load factor. So load factor, average load over maximum demand, MD. So yung mga symbol na ginagamit dito, acronyms doon sa kanilang mga term. No? MD, na-define na natin kanina si MD, that is only the maximum demand. Okay? Max demand. So that is the highest power na pwedeng mag-register doon sa ating load duration curve. No? Kapag sinuplayan natin itong 4 na load, so usually, no, para makita natin yung behavior ng ating load, so kinukuha natin yung data. So, pwede nating i-plot yan. So, this maximum demand, that is the highest load na nag-register dun sa ating load duration curve. And the ratio of average load over the maximum demand, that is always the load factor of our power station. Binanggit ng problem, that is 50% or that is simply 0.5. So, power factor, the overall operating power factor of our system, that is only equivalent to 0.8. So ano hinahanap? What is the approximate kilowatt demand of the customer? So approximate kilowatt demand, it is referring to the average load requirement of our customer. So what would be the average load of this given customer wherein this customer has 4 circuits with maximum demand in terms of ampere. So this average load, that is in terms of power. Okay? So kapag kinuha natin yan, since 3-phase tayo, so the average load in kilowatt, it should be equal kanino? Square root of 3 line voltage multiplied to the current. Saan natin kukunin itong current na to? So that is the average current. So that is the average current supplied to our customer or the average load current multiplied to sa kanyang power factor. So ibig sabihin, ang una natin kailangang mahanap itong current na yan. Since yung ating load in terms of current, so using diversity factor and the load factor, makukuha natin yung average load of the customer in terms of current. So pag nakuha natin ito, ipasok natin sa power formula, we have now the average load in terms of what? Kilowatt. So ito, in terms of current pa rin yan. So kunin natin yung maximum demand or the peak current, no, in terms of current. So lumalabas, in terms of current, your diversity factor, it should be equal to the summation of maximum current, okay, or MD. I-divide natin, that is the maximum demand in the given plant. So wala nang problema, makukuha natin ito, that the maximum demand in terms of current, that is simply summations of maximum demand in terms of current. So meron tayong apat na load. So first load, ang kanyang maximum demand is 35. The second circuit, its maximum demand is 46, then 72, then 57. I-divide natin diversity factor of 1.5. So therefore, yung maximum demand in terms of current na kailangan na i-provide ng ating power station, it should be equal to 35 plus 46 plus 72 plus 57 divided by 1.5. So that is only 140 ampere. So therefore, using the load factor, so pwede nating makuha yung ating average load in terms of current, which is equal to load factor multiplied to the maximum demand in terms of current. So ilan yung ating load factor? 50%. Multiplied na lang ng 140. So meron tayong 70 ampere. So that is the average current supplied to our customer. So therefore, we can have now the average load in terms of kilowatts, or that is now the average power consumption of this customer, which is equivalent to square root of 3 times. Ano yung system voltage? 220. Kailangan natin kilowatts, kaya gawin ko lang kilovolts, no? 0.22. Multiplied by the average load in terms of current times power factor of 0.8. So meron na tayong average load in terms of kilowatts. So times 0.5 times na lang natin ng 0.22 is square root of 3 times 0.8. So we have now the final answer, which is 21.3 kilowatts. So that will be the average load of our customer. 21.3, 21 kilowatts will do anong letter niya? Baligtad. Right? Diba? Any question regarding problem number 9? So as much possible, dapat yung diversity factor natin is mas malaki. So anong ibig sabihin? So kung papansinin mo, ito pa rin yung load na kailangan natin supplyan. So yung kailangan lang natin i-provide na maximum demand is only up to 70. Diba? 70 lang. So ibig sabihin, mas maliit. Ngayon, let's say, tignan mo kapatid, kung gagamit ka ng diversity factor of 1, let's say diversity factor mo is 1. Kung 1 ito, ano yung maximum demand mo? 140, ito pala, no? So si 140, ito na pala yung 1.5. So kung 1 yan, so 140 yung ating maximum demand. So kung ang diversity factor naman natin is 1 point or 1 lang, so 140, i-times ko na lang ng 1.5. So that is what? 210, no? Ito yung summation nito, that is 210. So kung ang diversity factor mo is 1, ibig sabihin, ang magre-register na maximum demand mo is 210. So anong ibig sabihin? So in order to provide the load requirements ng ating customer, so kailangan mo mag-provide ng isang generating station na merong capacity na 210 in terms of current. Okay? So malaki ito compared kay 140. So pag mas malaki, mas malaking capital ang kailangan mong i-consider. Pag malaki rin yung current, medyo malaki rin yung losses. Nakuha ba? Pero yung kinikita natin, yung binibil mo, eto pa rin. Hindi naman ito nagbago. Diba? So ngayon, kung properly manage yung time kung saan lalabas itong maximum demand. Tulad dito, diversity factor natin, ano lumabas na maximum demand? 140. So, ibig sabihin, so nakabase dito yung ating magiging capacity. Magpo-provide ka ng isang generating station na merong capacity na kaya mag-provide ng 140. So, i-compare mo yung 210 sa 140. Di hamak na mas maliit ito, maliit ang current, mas maliit yung losses. Pag mas maliit si current, mas maliit yung size ng ating equipment, mas mura. So, nakatipid ka na doon pa lang, doon sa capacity ng ating generating station. At ano pa yon? Hindi naman natin binago yung load. Ito pa rin yung iyong customer. Hindi nagbago. So, ibig sabihin, same pa rin yung pumapasok na income kay generating station, pero lumiit yung kanyang gastos. Bakit lumiit? Kasi properly time managed itong kanyang load. Nakuha ba? So, ganun din pagdating sa bahay, no? So, pare-pares lang naman yung, let's say, sa bahay mo, ito pa rin naman yung mga loads mo or appliances mo. Pero kung mapa-properly time manage mo kung kailan lang gagamit ng ganitong klase ng appliances, huwag mong isabay sa iba, so definitely, mas maliit ang magiging konsumo mo. Kasi hindi sabay-sabay yung load, so hindi nagkakasabay-sabay yung bulto ng current. Okay? Kasi alam natin, nakaparallel yan. So pag parallel, current is always additive. Kaya kung lahat ng equipment mo sabay-sabay na nag-ooperate, so ibig sabihin, mas malaki yung current. Okay? So alam mo na, pag malaki ang current, doon lahat nakabase. Okay? So kaya kailangan, diversity factor should always greater than 1. Okay, so iwan ko si problem number 9. So let us try number 10. So again, we have a certain customer with the following loads. Diversity factor ulit is 1.5. So what is the minimum ampacity of the feeder conductor? Tulad dito, ng kaparehas nito. Kanina, kung ang diversity factor mo is 1, so di ba nakabase sa current kung ano ang size ng conductor. So, ibig sabihin, kung diversity factor natin dito is 1, so dapat yung feeder conductor mo, ang minimum ampacity niya is 210. Diba? Pero kung gumamit ka ng diversity factor of 1.5, yung minimum capacity lang ng ating feeder conductor, it should be 140. Nakuha ba, kapatid? So, therefore, doon pa lang, nakatipid ka na. Mas maliit yung wire mo kasi mas maliit yung current. So, that is the same for problem number 10. So, magbabase ngayon yung ating feeder conductor depending doon sa maximum demand na kailangan nating supplyan. So, to get now the maximum demand na kailangan natin i-supply, so for problem number 10, so the current in terms of maximum demand, it should be again equal to the summation of the maximum demand of the load in terms of current. I-divide natin kanina kay diversity factor. So ano lumalabas? At this case, the given customer has the following maximum demand for every circuits. Isang 25, 38, isang 18, at isang 45. So, i-divide natin kay 1.5. So, ito yung ating maximum demand. So, ibig sabihin, dito ngayon nakabase kung anong size ng ating feeder conductor. So, ano lumabas? So, 25 plus 38 plus 18 plus 45, i-divide natin kay 1.5. Ano value? So, you have 84. So since kita mo na ng possible maximum current na pwede mong i-supply, no? Yung maximum current na kailangan mong i-supply sa ating customer is 84, so dapat doon nakabase yung size ng ating conductor. Hindi pwedeng lumiit yan. Kasi pagka lumiit yan yung kanyang capacity, ibig sabihin pag lumabas yung kanilang maximum demand, so underrated yung ating conductor. So mabilis mainit. And worse, baka mamaya masunog pa siya. Okay? So the answer, that is 84 ampere. Cuts time. So number 11. For number 11, the power customer is applying for a source wherein the loads are listed, no? The loads are listed as follow, no? Baligtad itong listed. So power customer is applying for a source for the load as listed, or source listed the load as follows. So the given loads of this customer, that is, it contained 5 motors, each 15 HP, another set of motor loads. So 3 5 HP motor, then lighting loads and miscellaneous loads. So the demand factor is 65%, and the power factor is 80%, wherein the load factor is 46. What is the maximum kilowatt demand for the given customer? So let us consider, kunin natin si CL. Sino si CL? This should be the connected loads. So pag kinuha natin si connected loads, that is only the summation, ano? So the summation of these corresponding loads. So kunin na lang natin yung ating connected loads. So let us just get the connected loads based on kilowatt, no? I-kilowatt na lang natin yung kanyang loads. Right. Yeah. So convert na lang natin yung ating HP into kilowatts, ano? Then, sino si demand factor? So, pag kinuha natin si demand factor, pag kinuha natin si demand factor, ano nga ba si demand factor? No? So, pag kinuha natin si demand factor, that is always the ratio of maximum demand over the connected loads. So, yun yung ating demand factor. So, kunin muna natin yung ating connected load. So, connected load, that is just the summation of the load for a certain customer. So, convert na lang natin lahat yan into kilowatts. So, based sa problem, this given customer, meron siyang sets of motors. Now, 5 sets of motor, each is what? 15 HP. So, kunin natin yung total HP, no? So, 15 times or 5 times 15, then convert natin into kilowatts, multiplied ko lang ng 0.746. Then another sets of motor loads, 3 sets, each is 5 HP. So convert ulit natin by 0.746. So para naka kilowatts. Then i-add na natin diretso yung kanyang lighting loads at saka yung miscellaneous loads. So siguro pang small appliances. So 8 plus 3.5. So we have already 11.5. So this would be the connected load for our customer. So ilan lahat ito? So 15 times 0.746, 15 kilowatt. So 5 times 15 times 0.746 plus 3 times 5 times 0.746 plus 11.5 na lang. No? So we have now its connected load equivalent to 78.64 kilowatts. So this given customer has a demand factor, DF, that is the demand factor. So pag kinuha natin ang demand factor for this given power station, that is always the ratio of its maximum demand over the connected load. So CL is connected load, MD is maximum demand. So this should be equal based on problem. We have only 65%, or that is 0.60 So load factor, alam na natin si load factor. Load factor, that is the ratio of average load over the maximum demand, which is equal to 0.46. So this case, hinahanap lang ng problem, what is the maximum kilowatt demand? So it is referring to maximum demand of our customer, and that is the MD. So using the demand factor, so that is the demand factor multiplied to the connected load. Alam na natin si demand given is 0.65 times connected load of 78.64. So we have now the final answer. 0.65 times 78.64. So we have 51.11. Anong unit? This is already in kilowatts. So 51 will do, anong letter yan? This is under Cat's time. Okay? So that will be our demand factor. So sa atin, sa design natin, sa electrical wiring design, so meron tayong sinusundan na table for the demand factor depending on the type of loads. Diba? So, pero unless otherwise, yung ating default demand factor, it is usually 80%. Pero for specific load, so meron tayong different demand factor na pwede natin i-consult dun sa ating PAC. So nandoon lahat yung possible demand factor per corresponding load. So one go, no? Let us try number 12. So for number 12, we have a diesel power plant. So usually, kailan ba ginagamit si diesel? So diesel, usually, pwede siya pang peaking load or pang standby or pang reserve lang. No, kasi nga naman, mahal masyado yung kanyang operational cost. So magkano ba yung diesel? So ngayon, lalo na ngayon, sa panahon ngayon, ano? Mas mataas pa ang presyo ng diesel compare sa gasoline. So let us consider we have a diesel power plant with overall efficiency of 30%, wherein the heating value of the diesel or the energy content of this diesel, so it can provide 18,000 BTU of heat per pound. So niya lang, no, yung ating fuel, although diesel yan, dapat volume ang ginamit is per pound of diesel. If the diesel cost, sana all, no? Sana ganito lang kaliit yung presyo. Kailan kaya ito, no? Anong panahon kaya itong 6 pesos per liter? Ngayon is 70 plus. So 6 pesos per liter. What is the fuel cost of production in peso per kilowatt hour? So take the density of diesel to be 900 grams per liter. So ito yung binabayaran natin dyan sa ating electric cooperative, no? Yung generation cost. So how to solve for the generation cost? So for number 12, so we have diesel power plant wherein its overall efficiency that is only 30%. So that is 0.3, wherein the heating value of our diesel that is 18,000 BTU per pound, wherein cost of fuel cost, sabihin na natin FC, 6 pesos per liters. So that is per volume. So let us just consider that the mass density, so mass density is mass per volume, ano? The mass density of this diesel, 900 grams per liter, 900 grams, or that is simply 0.9 kilogram per liters. No? So that would be its mass density. So hinahanap lang natin what should be the generation cost. So ito yung major component ng ating electric bill. That is the generation cost. So paano ba natin kukunin si generation cost? So that is always equal to the fuel cost over the output of our power plant. No? So that is always equal to generation cost. Kung gusto natin kunin si generation cost, that is always equal to the ratio of fuel cost or the capital, no? The capital used to generate this given electrical energy, fuel cost, i-divide na lang natin kanino? Kay output. Sino output natin? That is the electrical energy. Okay? So, saan natin kukunin yung ating electrical energy output? Kaya nagbigay sa atin ng plant efficiency. So, kung babalikan natin, plant efficiency in terms of energy, so, sino yung output natin? So, the output that is actually is electrical at yung ating input is mechanical. So, this is the ratio of electrical energy output over the mechanical energy input. So therefore, makukuha natin that the electrical energy output, that is just simply whatever the plant efficiency multiplied kanina, mechanical energy input. So si mechanical, alam na natin that this should be equal to whatever the mass of fuel, i-divide natin kanina or multiply natin kay heating value. Ngayon, walang binigay na mass. So therefore, kukunin natin si mass in terms of volume. Okay? So, ibig sabihin, kung kukunin natin yung electrical energy, kunin natin yung output electrical energy per volume of fuel. So, i-divide na lang natin ito ng volume of fuel use. So, therefore, nakadivide din dapat ito ng volume. So, ibig sabihin, ang magiging output natin is the kilowatt hour per liter of diesel. Now, ibig sabihin, this would be the output electrical energy per liter of diesel. So, pwede na natin kunin that the electrical energy output per given volume, it should be equal, ano plant efficiency? 30%, 0.3. Then, mass over volume, that is the density. Mass over volume, density. So, meron tayong 0.9, lagay ko ang unit, kilogram per liters. Multiplied natin, ano heating value? That is 18,000 BTU per pound. So, ang gagawin na lang natin ngayon kapatid, i-convert na lang natin si pound into kilogram. Ilang pound meron sa isang kilogram? 2.204 pound per what? Kilogram. Now, i-convert natin si BTU into kilowatt hour, that for every 1 kilowatt hour, how many BTU? 3413 BTU. Okay? Cancel natin si BTU, BTU. Cancel natin yung pound, pound. Cancel din natin yung kilogram, kilogram. So ano magiging output natin? Kilowatt hour per liter, and that is the output per volume of this given diesel. So ilan siya kapatid? So 0.3 times 0.9 times 18,000 times 2.204, that is number of pound per kilogram, i-divide na lang natin ng 3413. So this should be the amount of electrical energy produced per liter of diesel. So per liter of diesel, it can provide 3.138 na lang kilowatt hour per liters. Okay? So in that case, kuha na natin that the generation cost at this case, magkano fuel cost? So that is 6 pesos per liters. Ano magiging output natin? 3.138 kilowatt hour per liter. So cancel si liter at liter. So ano matitira? So that is in terms of peso per kilowatt hour. So 6 divided by answer na lang. So we have 1.91 peso per kilowatt hour. ang saya sigurong gumamit ng electricity kung ganito lang yung generation cost natin. 1.91 pesos per kilowatt hour. Napakababa ng ating electrical consumption siguro ng ating electric bill kung ganyan kaliit, no? 1.91, halos wala pang 2 pesos. Sana lang. Okay? Anong letter yan? So this should be baligtaran. Okay? Nakuha ba? So that should be our generation cost. No? Kung paano nga ba kino-compute yung generation cost na makikita natin doon sa ating mga electric bill. No? That is one of the major component na makikita mo doon sa ating electric bill. That would be the generation cost. Okay? Nakuha ba? Any question regarding problem number 12? So, kunin ko na sa number 13 before tayo mag-merienda. So, for number 13, if you have a diversity factor of 4.2, so gives a savings of blank percent in generating equipment. So, percent savings. So, sino ba si percent saving? Percent PS. Okay? So, percent savings, it is equal to 1 minus 1 over diversity factor. I-times na lang natin sa 100%. So kapag positive yan, so ibig sabihin nakapag-save ka. So kapag negative yan, loss ka. Ilang naman ibig sabihin nun. Sir, bakit siya naging 1 minus 1 over the diversity factor? Kasi computation yan, that is based on the maximum demand. So kung babalikan natin, your diversity factor is the summation of maximum demand of the load over the maximum demand in the given power station. So para makuha natin yung percent savings na yan, so ang comparison, so let's say, kung ang diversity factor lang natin is 1, so if that is diversity factor is 1, sabihin natin, this is diversity factor is 1. So kukunin natin itong ating initial maximum demand. So let us consider, para makita natin, let assume, let the summation of maximum demand of a given customer, sabihin na lang natin is 100. So therefore, pag gumamit lang tayo ng diversity factor of 1, so yung ating magiging maximum demand, it should be also 100. So let's say 100 megawatts. So ibig sabihin, you have to provide a generating station with at least 100 megawatt capacity kung ito is megawatts. Okay? So kung diversity factor mo is 1, so therefore lumalabas kung ang maximum demand ng ating customer is 100 megawatt. So to provide this one, you have to provide a generating station with at least 100 megawatt capacity. Now, let us consider, applyan natin ng diversity factor. So let us provide a proper time management for this given load. So at this case, let's say ang binigay sa atin, this is not 42, 4.2. So anong lalabas na maximum demand natin? MD sub 2. Okay? So the maximum demand at this case, it is equal kanino? 100 na lang, i-divide natin ng 4.2. So ilan siya? 23.81. So yan na lang yung magiging maximum demand natin. So ibig sabihin, same customer tayo, pero ito lang yung kailangan mong i-provide. Dati, ganito kalaki yung iyong generating station. Ngayon, ito na lang kasi properly time managed na yung ating mga load. So ibig sabihin, Dating nagpo-provide ka ng 100, ngayon ilan na lang ipo-provide mo? 23.81. Nakuha ba, kapatid? So ibig sabihin, gaano kalaki yung natipid mo doon sa iyong generating station? That is 100 minus no answer, which is equivalent to what? 76.19. So that would be the savings mo agad doon pa lang sa generating station, doon sa iyong capacity. So, eto, pwede natin ipasok dito. That is the same. Kapag kinuha natin yan, this is 1 minus 1 over 4.2. So you have also 76.19. Naka-percentage na. So that is the diversity factor. So ibig sabihin, this given percent saving, pag dinerive natin yung kanyang formula, the percent saving, that is just simply equal to initial maximum demand if you have diversity factor is 1. So minus MD2, i-divide natin kanina. MD2. O, paligtad no. Tama. Baligtad. So this should be siyempre reference MD1. Yan. Times 100%. Okay? So that would be the percent savings. No? MD1 minus MD2 over MD1. So MD1, this is the maximum demand in the given power plant if diversity factor is 1. Then MD2, that is the maximum demand if diversity factor is what? Diversity factor 2, which is 4.2. So using this equation, you may also get the power or the percent saving. Or pwede nating i-simplify, no? Pagka distribute natin, MD1 over MD1, so that is simply 1. Then MD2 over MD1. So check natin. So this is also equal, no? You have 1 minus MD2 over MD1. Now, express natin si MD2. So, alam natin, MD2, that is equal to the summation of maximum demand of the load, i-divide natin sa kanyang diversity factor. Now, ito, ganun din. No? You have the summation of maximum demand of the load over the diversity factor. Ito sub 2, ito sub 1. Eh since iisang load ang pinag-uusapan, pwede natin itong i-cancel. Eh alam natin, diversity factor 1, that is simply 1. Kaya anong matitira na lang, that is 1 over whatever the given diversity factor greater than 1. Kaya lumabas itong equation na to. Okay? So itong equation na to, at saka ito, they are just what? The same. So kapag lumabas na positive, ibig sabihin, nakasave ka. So pag lumabas dito is negative, ibig sabihin, nalugi ka pa. But basically, kapag dinagdagan mo yung diversity factor, so definitely, makakatipid tayo. Kasi lumiliit yung ating equivalent generating capacity o yung maximum demand na kailangan nating i-provide, wherein yun din yung ating magiging basis for our capacity. Nakuha ba, kapatid? Any question regarding problem number 13? So therefore, no, nakuha na natin kanina that the percent saving, that is only 76.19%. 1 minus 1 over 4.2. Multiplied na lang natin ng 100. So this is 76.19%. So nakatipid ka ng 76.19% dun sa ating generating station. So 76%, pwede na. Anong letter yan? So this should be dog style. Okay, kuha? Any question regarding problem number 13? Kaya nga, napaka-importante ng diversity factor or time management of this corresponding load. Okay, so merienda muna tayo. Let us have a short break before natin ituloy dun sa natitira problem. Merienda muna. Okay, so let us continue. So let us try for problem number 14. So for number 14, a certain amount of fuel can produce 100 watts of energy. In how many days will the fuel be totally consumed if it is used to satisfy a demand of 10 raised to 14 BTU per day at a power plant with overall efficiency of 20%? Okay? So let us consider no fuel. So pwede na sabihin this is again under sabihin na lang natin that is diesel power plant. Ano? So based sa problem, a certain amount of fuel can produce 100 watts of energy. So ibig sabihin nun, we have the mechanical energy input of this given power station in terms of watt, that is 100 quads. Okay, with a plant efficiency which is equivalent to 20%. So in how many ways or in how many days will the fuel be totally consumed? It is used to satisfy a power demand of 10 raised to 14 BTU per day. So sino yun, no? So that is actually the power consumption of the given customer or the output power of our generating station per day, which is 10 raised to 14 BTU per day. So energy per given time, that is actually power. So ano hinahanap? So gaano katagal bago maubos yung ating reserve energy? No? Gaano katagal bago totally makonsume yung ating given source of fuel? So T in terms of what days? Now, kung babalikan natin, no, the plant efficiency, that is always equal to electrical energy output over the mechanical energy input. Ano? At alam naman natin, electrical output, that is the power demand or the output power multiplied by time. No? I-divide natin. So, given na yung ating mechanical energy input. So, at this case, kita na natin, ano? Cross-multiply na lang, we can have now that the total number of days at which this given fuel will be totally consumed, it should be equal whatever the plant efficiency multiplied whatever the available source of energy, i-divide natin sa daily power or their daily energy consumption, or that is the power consumption per day. So we have now plant efficiency of 0.2 multiplied 100 quads, gawin nating BTU. So alam natin per BTU or per quad, there are 10 raised to 15 BTU. So i-divide na lang natin the power consumption per day, that is 10 raised to 14 BTU per day. So this is BTU na, kasi na-convert na natin. Then this should be BTU per day. So kita na natin, no, cancel ito. So the unit, it should be in terms of number of days. So the given energy will be totally consumed within how many days? So it would last only within 200 days. So after 200 days, so totally consume na yung ating fuel. Okay, pa ba? So that is only if, no, alam natin, no, the power consumption o yung load requirements is variable. So dito, yung changes, okay, yung increase in the power demand is negligible. So ibig sabihin, ano, itong output power per day or the energy consumption per day, it is held constant. Walang changes. But actually, reality, nagbabago yan kasi alam natin, load is variable. So habang patagal ng patagal, so pataas ng pataas yung load requirement ng ating customer. Bakit pataas ng pataas? Kasi alam natin, habang tumatagal, kahit pa paano, nadadagdagan yung ating mga customer. So lumalaki yung population ng community. As the population increases, so definitely the power demand or the power consumption also increases. So dito sa problem 14, so negligible yung increase sa power consumption ng customer, or pwede sabihin constant yung power consumption ng certain customer. Okay? So ba? Kaya within 200 days, so totally consumed, totally ubos na yung ating mechanical energy na naka-inbound, no? Kumbaga yung reserve energy natin na 100 watts. So after 200 days, so totally consumed na. So ano letter? Meron man 200, ayun. So that should be catch time. So iwan ko si number 14. So let us try to solve for number 15. So for number 15, a natural gas reserve, no? A gas power plant or natural gas power plant. So the natural gas reserve in the given country is estimated to be 100 times 10 raised to 9 yan, ano? So the volume of fuel available, yung reserve gas is 100 times 10 raised to 9 yan. Cubic feet of gas available. So we have 100 times 10 raised to 9 cubic feet of gas available in a certain country. So this would be the gas reserve, no? With an energy content, so the heating value of this given gas reserve, so it can provide of 0.025, so instead of kilowatt, so and expressed in watt year per cubic foot. So 1 cubic foot of this gas, so gas reserve, so it can provide 0.025 watt year. So kung gusto mo express yan in terms of kilowatt, so pwede mo i-convert itong year into number of hours. No? I-times mo na lang yan ng 8760. So makakuha mo yung kanyang heating value in terms of watt hour. Dito, in terms of year. Now, if the present power demand is 0.5 gigawatt and the power demand growth rate is 5%. So tulad nga na binanggit ko kanina, reality, so yung power demand or yung power consumption ng ating customer o ng community increases because of the increase of population. So the demand growth rate is 5%. So this is yearly. So every year, the power demand increases by 5%. And all energy will be supplied by natural gas. So approximately how long will the reserve last? So almost similar kay problem number 4. The only difference kay number 4, constant yung power consumption. So dito, every year, increased by 5%. So let us consider initially at T sub O, or that is at time equal to 0, or that is when the given gas will be used now to supply the power energy. So the initial power demand of the given customer, that is equal to 0.5 gigawatts. Now, alam natin, as time increases, no, habang tumatagal yan, at any given value of t, so the population increases, no, the population of the community increases, so therefore, the corresponding power demand increases. So based sa problem, habang tumatagal, we have observed that the growth rate, no, so B, ito yung ginagamit na symbol, na hindi ko babaguhin, that is the growth rate factor. So this would be the speed at which the power demand increases every year. So every year, the power demand is increased by 5%. So hinahanap ngayon ng problem, how long ulit, no? So required itong T na to. Gaano katagal? How long before this given natural gas na available will be totally consumed. So again, that would be the corresponding T. Yun nga lang, measured now in terms of years. So ilang taon. So paano natin kukunin yan? Ano? So ulit, para makuha natin yan, let us try to consider, no? Kapag pinlat natin yung kanyang load duration curve, ito siya, no? So this is the power consumption. And this would be the time. So let's say at time equal to 0. So ito yung ating minimum power demand. So that is our P sub O, which is 0.5 5 gigawatt hour. Now, due to the increase of population, this power demand or power consumption increases by 5% every year. So kapag kinuha natin yung curve yan, so pataas yan, no? Increases exponentially. So yan yung ating magiging load duration curve. Habang patagal ng patagal, the power consumption increases. Because of what? Unang-una, increase of population. So hinahanap ng problem na yun is how long would it take before the total reserve will be totally consumed. So let us consider this would be the value of t. So paano natin kukunin yung time na yan, kapatid? So therefore, kung kukunin natin itong equation ng curve na yan, since you have increase of power demand due to increase of populations at nandito na mismo growth rate factor, so ibig sabihin this given curve the increase of power demand of a certain community follows the law of growth dun sa ating differential equation. So kung naalala niyo sa differential equation, that is law of growth, so pwede nating sabihin that the rate at which the power consumed changes with respect to time, it is always proportional dun sa kanyang initial power consumption. So that is the rate of growth. So kapag kinuha natin yan using differential equation, equal, so maglagay tayo ng constant k. So that is your p. Proportional, kung dito, to any or proportional to the power consumption at any given time. Ngayon, so solve natin tong differential equation na to para makuha natin tong equation na yan. So kayang-kaya na ito, this is only using variable separable. So lalabas diyan, kapatid, that the power consumption at any given time that is equal to initial value, initial power consumption, that is e raised to positive kt. So sino tong k na to? Ang tawag natin kay k sa differential equation, that is also the growth rate factor. Pero pagdating kay power plant, hindi k ang ginagamit. Instead, it is using what? B. Okay? So, etong k na to, that is also the value of b. So, pwede natin palitan that this given equation, p, it is equal kanino. That is the original power demand e raised to bt. So, kailangan natin makuha ito. Okay? So, paano natin kukunin itong value ng t na yan, hindi natin alam kung ano na itong power at this given value of t. Kasi hindi natin alam kung kailan ito. Alam natin ito, alam natin si b, pero hindi natin alam anong value ng t. Kung saan, you have now the corresponding power. Okay? So, saan natin kukunin yan? Kung babalikan natin yung ating plant efficiency in terms of electrical energy output over the mechanical energy input. So kapag kinuha natin yung electrical energy output or the total energy consumed by this customer within this given period of time, so our electrical energy output, that is equal to the plant efficiency multiplied kanino? Mechanical energy input. So ang kukunin nating electrical energy output, that is the total energy consumed by our customer from the start until this given gas is totally consumed. So saan natin kukunin yon? So in order to solve that, kailangan natin kunin ngayon yung area under this given curve. So pag kinuha natin tong area under this load duration curve, so area, So that is the product of power multiplied T. So that is the electrical energy output. So this is the total energy consumed by our customer from 0 year up to T years wherein this fuel is already totally consumed. So paano natin kukunin yung area niyan? Eh hindi ito trapezoidal. So at this case, gagamitan natin ng konting integration yan. So gagamit tayo ng vertical strip. Right? So getting now the corresponding electrical energy consumed. So gamit tayo ng area. So to get its area, so ito yung ating dt at ito yung ating P. So therefore, the area of this curve represent the electrical energy output. So the electrical energy output natin, that is equal to integral ng ating P dt from what? From 0 to T. Ano value ng ating P? Yung nakuha natin equation based on the law of growth, that is P sub O e raised to B T dt from what? 0 to T. So pag in-integrate natin yan, kapatid, we have only 1 over B output power e raised to BT. Approach limit 0 to T. So upper minus lower. So ano lumalabas, kapatid? This is now equal to 1 over B output power quantity e raised to, so upper limit is T. So palitan mo si T ng P, so that is still BT minus lower limit, T is 0, e raised to 0, that is simply 1. So that would be our total electrical energy consumed from 0 year up to T years, which is always equal kanino? The plant efficiency multiplied kanino? Mechanical energy input. At alam na natin ano formula ng mechanical energy input. Ayun na, nakikita na natin kung paano solving itong time na to. So, makukuha na natin itong tinatawag. So, complete simplification na lang, cross multiply, divide. Okay, then plus 1 para makuha ito, take the logarithm of both sides. So simplified natin itong equation na to solve for the value of t. So lumalabas, the total time before the corresponding reserve fuel will be totally consumed. It should be equal to so ito, cross multiply, divide, plus 1, take the load. Okay. So this is 1 over B loan of the quantity, plant efficiency, mechanical energy input, multiplied the growth rate factor, divide by the initial power demand. So ito, kapatid, transpose, so plus 1. So this is now measured in terms of year. So yun ay ating formula. So this will be the formula in order to determine how long would it take before the given amount of fuel will be totally consumed if we have to consider the growth rate factor. So the growth rate factor, that is the yearly increase in the power consumption of a certain community. Now, alam na natin kung ano yung ating mechanical energy input. At this case, volume ang given. So that is the volume of fuel multiplied kanina, heating value. So wala nang problema, pwede na nating diretsuhin. So the total number of years equal to 1 over aning growth rate factor 5%, so 0.05 multiplied loan. Sir, wala pong binigay na efficiency. So kung walang binigay na efficiency, gusto natin ang isang system, ano efficiency? 100%. So kung walang binigay na efficiency, let us consider the efficiency is what? 100%, or that is simply 1. Okay? Mechanical energy input is the volume of fuel multiplied by the heating value. So yung volume of fuel available, that is what? 100 times 10 raised to 9. Raised to 9 is giga. Eh ang initial power demand natin is giga. So, 10 raised to 9 canceled kay giga, no? Para hindi ko na isama yung 10 raised to 9. Okay? So, yung 100 na lang. Multiply growth rate, which is 0.05. Divide, so 0.5 na lang. Yung giga nito, nung giga ng power demand at time equal to 0, at saka yung 10 raised to 9 itong volume of fuel, magka-cancelled out na lang. Ano? Then sa dulo, plus 1. So we have now the total number of years at which this fuel will be now totally consumed. So 1 over 0.05 times loan of 100 times 0.05 divided by 0.5 plus 1 na lang equal 100.05 plus 1. Anong kulang ko? 47. Ayun, hindi ko na isama yung heating value. Kaya pala iba lumabas na value. Wala pa si heating value dito. Ano heating value ng ating fuel? 0.025. Kaya pala iba lumabas. Ayun, 0.025. Okay. So, dagdagan ko lang sa taas. Wala yung heating value, 0.025. Mechanical energy, that is volume of fuel. Ito yun, 0.025. That is the heating value of the given fuel or the given gas. So, equal. So, sakto na yan. Ano labas? You have 4.46 years. So within 4.46 years, this given reserve gas will be totally consumed. No? It can last only for about 4.46 years. So anong letter yan? So that should be cast iron. Okay? So dapat ito rin yung equation natin kay problem number 14. However, kay number 14, no, hindi binigay yung growth rate factor. So ang ating assumption, so constant yung power consumption. Constant yung power consumption. Kasi kita naman natin, hindi aabot ng taon. So ibig sabihin, so wala pang increase sa power consumption kasi it takes only for about how many days? 200 days. So wala pang isang taon. Kaya wala pa talagang growth rate. So usually this growth rate that is per year basis. Okay? Ako ba? Any question regarding problem number 15? So iwan ko siya. Let us try number 16. So for 16, a power plant that consumes 100,000 pounds of coal per hour. So the mass of coal that consume per given hour, it is equal kanino? No, kada isang oras, so the total amount of coal that is being burned, that is 100,000 pounds per hour. No? Kada isang oras, 100,000 pounds of coal ang sinusunog in order to provide a certain amount of energy. If the heating value of this coal is 12,000 BTU per pound, the overall efficiency of the plant, coal-fired power plant, is 30%. So what is the kilowatt output? Okay. So hinahanap lang natin what is the output of our generating station. So that should be our example. Okay, so ulit, balikan lang natin si plant efficiency. So alam natin the plant efficiency in terms of electrical energy output, that is the output power multiplied by the given time. I-divide natin sa mechanical. Mechanical is the mass of fuel multiplied kanina, heating value. So ayun na yung hinahanap natin. You just cross multiply. Lumalabas that the output power, it should be equal to plant efficiency mass of fuel, i-divide ko na lang na time multiplied kanina, heating value. So lahat andyan na, so kailangan na lang nating habulin yung required na unit na kilowatts. Okay? So wala nang problema, this is 30%. Mass of fuel use 100,000. So ilagay ko rito, this is in terms of pound per hour. Multiplied heating value. So the heating value that is 12,000. BTU per pound. So anong kailangan natin unit? Kilowatt. So alam naman natin that for every 1 kilowatt hour, how many BTU? 3,413 BTU. So pwede natin i-cancel si BTU. Pwede i-cancel yung pound. Pwede rin natin i-cancel itong hours na to at saka yan. So anong natirang unit? That is kilowatt. Okay? So 0.03 or 0.3 rather times 100,000 times 12,000, divide na lang natin ng 3,413. So we have now the final answer. So that is in terms of kilowatts. Di ba sumobra yung aking 0.3, 100,000, 12,000, then divide by 3,413. Sakto lang. So, ilan ito kapatid? This is 1, 3. Yung one, 0,54790. 0.51 kilowatts. So that should be our answer. Oops. Sumobra ba? 0.3, 12,000 BTU per hour. Per hour heating value. So, ito naman, 30%, 0.3 times 100,000 per hour times 12,000 divide by 3,413. Ayun. Ano sobra kanina sa point ko? Tingnan ko nga, ano sobra sa point kanina? Eto. Naging 120,000 pala itong isa kanina, kaya pala sumobra ng isang decimal. Sumobra ng isang zero yung aking input sa una, kaya pala sumobra ng isang decimal. So it should be 105,479.05 kilowatts. So that should be the answer. So pwede na natin i-consider 105,500 kilowatts. So that is at Dodge type. Sumobra ng isang zero yung aking heating value. Instead na 12,000, naging 120,000 yung aking napindot. Kaya pala sumobra rin ng isang decimal yung aking final answer. Okay? So I want ko si number 16, number 17. A 100 megawatt power plant has a heat rate of 2.88 times 10 raised to 6 calories per kilowatt hour. So 100 megawatts, so it represents the installed capacity for this given power station. So the heat rate, so that is our Q, which is 2.88 times 10 raised to 6 calories per kilowatt hour. It is base load plant, no? Base load power plant. So, sino si base load? So, base load power plant, these are the power plant that usually operate during normal condition, and it is expected to supply energy within 24 hours a day, no? Theoretically. So, it is a base load power plant and runs at full load for 24 hours a day. So, how many tons of coal is needed per day? Okay, so how many tons of coal needed per day? So you have the installed capacity and you have the heat rate. No? Pag kinuha natin si heat rate, diba, the heat rate, that is the reciprocal of your mechanical energy input over the electrical energy output. Okay, so getting now the corresponding mechanical or the electrical energy output. So the electrical energy output, that is equal to the output power multiplied by given time, which is equal to whatever the mechanical energy input. Ano ba mechanical energy input natin? That is the mass of fuel multiplied kanino? Heating value, i-divide natin kanino? Heat rate. Q. Eh sir, ano po yung output power natin? Maliwanag sa problem that the given power plant operates at full load. So kung full load yan, ibig sabihin, whatever its installed capacity, it is totally supplied to our customer. So the output power, at this case, it is equal to its installed capacity. Since the given station is operating at full load within how many? 24 hours. So ano yung nahanap natin? That is tons of coal needed per day. Okay? So, ito siya kapatid. Mass of fuel yung hinahanap natin. So, solving for the mass of fuel, so pwede na natin sabihin that is simply equal to whatever the installed capacity, ano? Installed capacity multiplied etong T, kasi per day, so ibaba ko na lang etong T. Kasi per day ang kailangan natin. So, mass per given time. So, you have the installed capacity. Multiplied na lang natin kanino? Kay heating value. Baligtad kay heating value. Kay heat rate. I-divide natin kanino? Heating value of the given coal. Okay? So, we have the installed capacity, we have the heat rate, i-divide na lang natin kanino? Heating value. Ang problema lang dito sa problem, walang binigay na heating value for this given coal. Okay? So, kapag ganyan, wala naman tayong standard na heating value for coal kasi alam natin, meron tayong different classes of coal. Ano? So, pwede tayong kumuha. So, let's say kay number 16, we have the heating value of coal. So, let us use, this would be the heating value of our coal. So, check natin. So, let HB is equal to 12,000. That's considered, that is in terms of BTU per pound. Okay? So, that is BTU per pound. So, therefore, wala nang problema, kapatid. Ano? So, the mass of coal needed per day, ano installed capacity natin? That is 100 mega. Eh, si heat rate is naka per kilowatt. So, itong 100 mega, gawin kong kilo. So, we have 100,000 kilowatts multiplied kay heat rate. So, that is 2.88 times 10 raised to 6. So, calorie per kilowatt hour. Okay. Then, i-divide natin kanino? Heating value. Ano heating value? So, 12,000. Anong unit nga lang ito? That is BTU per pound. Calorie sa taas. So conversion na lang that there are 252 calorie per BTU. No? Para mag-cancel yung calorie sa taas. Higit na ko lang ito. Yan. Okay? So anong matitirang unit? Cancel itong kilowatt, kilowatt. Magka-cancel yung calorie at calorie. Sino pa ang magka-cancel? Yung BTU at BTU. So anong mangyari? Tataas itong pound. Anong magiging unit? Pound per hour. Ang kailangan natin is ano? Per day. Alam natin, 24 hour a day. So i-convert na lang natin. Ilagay ko dito sa taas. There are 24 hours per day. Okay? Now, ano pang kailangan? Tons. Okay? So, kailangan natin i-convert si pound into tons. At alam natin, kapatid, that there are 2,000 pound per ton. Okay? So, pwede na natin din i-cancel itong pound sa pound. Sino pa ang pwede i-cancel? So, pwede rin natin i-cancel na itong hours sa hour. So, tataas itong tons. So, we have tons per day. Okay? So, that is the required amount of coal needed for this given coal-fired power plant. So, this is the amount of coal consumed per day. So, ano lumabas kapatid? So, we have only 100,000. Baka sobra na may 0 times 2.88 exponent of 6. At saka na lang natin i-multiply ng 24. So, sa baba, let us use heating value of 12,000. Sobra na isa. Convert BTU into calorie multiplied by 252. Then convert pounds into tons, 2,000. Tsaka natin equal. So, ilan ito kapatid? So, meron tayong 1,142. Kaya lang wala dito yung 1,142. Okay? So, ano yung possible reason? So, possible reason, ang ginamit na tons dito, hindi yung short tons. Kasi we have different tons, ano? Meron tayong tinatawag na short ton. Pag short ton, it is 2,000 pounds. Kasi wala naman default kung sinong ton ang gagamitin natin. Meron din tayong metric ton. Pag metric ton, that is 2,204 pound. Okay? So, masyadong mataas ito. So, possible, ang ginamit na conversion ng pound into ton ay yung metric ton. So, instead of using 2,000, gamitin natin yung metric ton na 2,204. So, nagagawa, babaguhin ko lang itong 2,000 na to. Gawin ko lang siyang 2,204. Equal. So, you have 1,037. So, wala pa rin yung ating 1,037 dyan. Ano yung possible reason? Kasi nga, hindi natin alam kung ano yung exact heating value ang ginamit. Okay? Hindi naman binanggit kung ano yung exact heating value ng ating given coal. So, ginamit lang natin is 12,000. Now, pwede rin naman, gamitin natin yung ibang heating value. So, ano pa yung heating value? So, meron tayong, ito, diesel ito, heating value ng diesel. Then, we have also coal here. Ayun, no? This is also a coal, wherein its heating value is what? 13,000. So, ibig sabihin, mas mataas kasi mataas yung number of pounds na ginamit natin or mas mataas yung lumabas na sagot. Lumabas na computation natin compared dun sa given data. So, ibig sabihin, dapat yung heating value ng ating code, so mas mataas compared dito sa ginamit nating 12,000. So, let us use 13,000. So, kung 13,000 ang gagamitin natin, ano magiging value? Yan. So, ang gagawin lang natin, babaguhin ko itong heating value instead na 12,000, gawin ko 13,000. Then, the given conversion is metric ton, 2,204. Palagi ko, andyan na yan. Ayun, 957. So, ibig sabihin, kapatid, at this case, ang ginamit natin, no? Ang ginamit na value, hindi siya 12,000 BTU. Instead, in this problem, it uses what? 13,000 BTU. That would be our heating value. And in terms of ton, it uses the metric ton. Kaya instead of 2,000, we have to use here 2,200. So in that case, kuha natin yung final answer, which is 957.3. Anong unit na yan? That is already in terms of pound per day. Nakuha ba? So, nag-trial and error tayo sa heating value ng ating coal kasi walang binigay na heating value yung ating coal. Eh wala naman tayong standard kasi si coal, iba-iba ang kanyang heating value depende do sa kanyang class. May mga class yung mga coal na yan. No? Meron tayong class A, class B, class C. So si class A, siya yung pinakamataas, kumbaga, siya yung pinaka-quality. So pag quality yan, mas mataas yung kanyang heating value. So usually, the heating value of coal ranges from 11,000 up to 15,000 depending on its corresponding class. Ngayon, pagdating naman sa ton, wala naman tayong default na palagi is short ton or metric ton. Kaya kung wala yung short ton, so pwede mong gamitin si metric ton. Okay? Or babanggitin rin ng problem kung gagamitin natin conversion is short ton ba or metric ton. Okay, nakuha. So at this case, we use metric ton and heating value is 13,000. So our computations is 957, which is closely enough. Pwede na natin i-consider that is what? 960 pound per day or 900 ba't pound ito? 960 tons per day. Tons per day na yan. Nakuha ba, kapatid? Any question regarding problem number 17? Kaya kung papansinin mo dyan sa ating power plant, usually ang computation yan, unit analysis na. Kaya dapat medyo sanay tayo sa mga units. Ano? By using units analysis, so madali nating makukuha yung mga required value. Yun nga lang, kailangan familiar tayo sa different conversion factor ng different quantity, ng mass, ng force, ng energy, okay? Ng ano po ba, no? Yung power, so on and so forth. Okay? So iwan ko si number 17. So number 18. So number 18, bumalik lang kay hydroelectric power plant. So hydroelectric power plant generates 100 megawatt at an available head of 200 with overall efficiency. What is the quantity of water in cubic meter per second is required? So alam na natin, kapatid, that the plant efficiency for hydroelectric power plant in terms of output power, i-divide natin kanina theoretical power of running water and the theoretical power of running water, that is QWH, at given na sa atin yung kanyang efficiency which is 75%. So given na yung output power, the effective head, makukuha natin yung amount of water in cubic meter per second. So cross-multiply na lang natin yan, lumalabas that the amount of water needed, it should be equal. Ano yung ating output? 100 megawatts, gawin natin kilo. 100,000 kilo. Okay? Divide natin efficiency, 0.75. Yung ating weight density for water, gawin din natin kilo, 9.81. Effective height, which is what? 200. So automatic, ang unit ito, it is already in cubic meter per second. 100,000, baka sumobra na sa 0, divide by 0.75 times 9.81 times 200. So we have 67.96 cubic meter per second. 68 will do anong letter? So that should be arriba. Okay. Number 19. So for number 19, a power plant has a maximum demand of 15 megawatts. So maximum demand, that is MV, which is 15. So we have annual load factor, LF. Sino nga si LF? LF is average load over maximum demand. Ilan siya, kapatid? 50%. Then we have the capacity factor, plant capacity factor. Sino si plant capacity? PCF. That is the total energy produced over installed capacity multiplied kanino? P sub R. Ilan daw ito? 40%. So ano yung nahanap? What is the reserve capacity? RC. So paano nga ba kunin yung ating reserve capacity? So simple lang, no? To get the reserve capacity, that is whatever your installed capacity, i-minus mo yung maximum demand. Okay? So your installed capacity minus the maximum demand, so that is your reserve capacity. So you have a maximum demand of 15 megawatts. So para magkaroon ka ng reserve capacity, kailangan yung iyong installed capacity is greater than 15 megawatts. Okay? So saan natin kukunin yung ating installed capacity? Eh meron na tayong maximum demand, which is what? 15. So kung kukunin natin si PCF, nandun si installed capacity. However, wala tayong P sub R. No? So let's say this is annual. So alam na natin itong P sub R kasi annual load factor. So annual din ito. So TEP, kung babalikan natin, so TEP, that is average load multiplied kanino? Actual service R. I-divide natin kay installed capacity multiplied kanino? P sub R. So that is our PCF. So problema natin, hindi binigay yung actual operating R at which this power station is operational and servicing its corresponding load. So walang binigay dito, anong pwede natin gawing assumption? So at this case, there is no data for S sub R. So ang pinaka-safe assumption, let us consider a base load power plant. So pag sinabi natin base load power plant, so let's consider a base load power plant. So kapag base load, theoretically, it is assumed to operate 24 hours a day, 7 days a week. So in that case, for a base load power plant, it is always assumed that the actual service hour, it is approximately equal kanino? P sub R. Okay? Kasi theoretically, dapat yung ating base load ay operational yan 24 hours a day, 7 days a week. Okay? Nakuha ba, kapatid? So in that case, pwede nating sabihin, lumalabas at base load power plant, PCF, it is also the ratio na lang nino, average load over the installed capacity. So makukuha na natin si installed capacity. Installed capacity is average load. So average load multiplied or divide kanino? PCF. Saan natin kukunin si average load? Meron tayong load factor. Average load is load factor times maximum demand since meron tayong maximum demand. So lumalabas, this is load factor times maximum demand, that is average load, i-divide natin kanina, PCF. Okay? So therefore, substitute na lang natin dito yan para isang compute tayo. Ito ipapasok natin dyan. So you may consider that the reserve capacity factored out natin si maximum demand, it is quantity equal kanino? Now you have load factor over PCF minus 1. So that would be also your reserve capacity. Kaya kung naalala, direct substitution yan. Ano? Reserve capacity, maximum demand in terms of kilowatts kasi naka-kilowatt yung ating reserve. 15 mega in kilo is 15,000. Load factor is 50%, PCF is 40%, minus 1 na lang sa dulo. So we have reserve capacity measured in kilowatts. Okay, 15,000 times 50 over 40 minus 1. So 3,750 kilowatts. So that should be our reserve capacity. So anong letter yan? This should be valid data. Okay, ba? Any question regarding problem number 19? No? Doon sa ating reserve capacity. So kunin ko si number 20. Sakto, 20. Sarado. So number 20, a plant said to have use factor. So sino yun? No? That is your plant use factor, PUF. Anong formula? TEP over installed capacity multiplied to the actual service hour. So based sa problem, that is 48.5%. Then we have the plant capacity factor, PCF, which is TEP over installed capacity times the total number of hours within a certain period at anong value? 42.4. How many hours did it operate during a year? So obviously, hinahanap ng problem the actual service hour rendered by the power station. So we are looking for S of R. So saan natin kukunin? So using PUF and your PCF, so if we try to divide these two, no? Divide natin ito. Kung iisang power plant ang pinag-uusapan, so ibig sabihin, parehas yung iisa ang kanyang total energy produced. Cancel. Iisa ang kanyang installed capacity. So pwede natin i-cancel ito. So anong makikita natin? So pag kinuha mo yung ratio, you may have that PUF over PCF that is actually equal. So tataas si P sub R, sa baba sino? S sub R. Okay, kapatid. So kapag kinuha mo reciprocal niyan, kunin natin reciprocal, so lalabas PCF over PUF. It is the actual service hour over the total periodic hour at ang tawag natin dyan yung ating SF. Ano yung SF? That is the service factor. So that is the service factor. So using this service factor, kuha na natin. Therefore, actual operating hour, that is the total number of hour within a certain period multiplied to your PCF over PUF. So, kailan natin kinukuha yan? Ano yung period na pinag-usapan? During a year. So, during a year, ano yung total number of hours? Nakuha na natin kanina, 8,760. PCF given, 42.4. PUF, 48.5. So, we have now the total number of hours. So, ilan yan kapatid? 8,760 multiplied 42.4 over 48.5. So the given power station operate a total of 7,658.2 hours. So yun ang ating final answer. 7,658 will do. Anong letter? This should be cut style. Okay? Nakuha ba kapatid? Any question regarding the power plant operation? So yung ibang problem dito, naibigay ko na rin yung formula, so pwede nyo nang diretsuhin. Tulad dito, what is the annual energy produced? Annual energy produced, it is referring to TEP, total energy produced. So annual lang, ibig sabihin, kukunin natin yung actual service hour within 1 year. Ito si SR. Okay, kaya given din ulit yung kanyang annual plant capacity at saka use factor. So using the service factor, makukuha mo yung ating actual service hour. And using the load factor, makukuha mo si average load kasi given naman yung maximum demand. Okay? So kayang-kaya nang solving yung ibang natitirang problem dito. Okay? Sa the rest, it is just objective. So any more questions, kapatid? Ibigay ko na lang yung answer doon sa objectives natin, no? Isasama ko na lang doon sa solutions na i-attach doon sa ating group. Okay, so any more questions, kapatid?